All right, guys. Hopefully got some juice now in the Apple Pencil. Let's continue with these notes. So we were talking before about this idea of a box and whisker plot. So this is the new concept for today. You can read what it says. It basically displays the 5 important summary stats in it. And again, those are the min, Q1, the median, which is the same as Q2, Q3, and the max. All right. These are really good at showing the spread, right? If you have a very narrow, like if the box and whisker plot was the whole length here from 1 to 4, it'd be very narrow spread. And so it allows us to talk about the spread, and they allow us to talk about the shape, which means skewed or evenly distributed, which is like uniform. Which is like symmetric. Okay, you can make them either horizontally or vertically, but commonly they're horizontal, which is how this is. So let's do an example by hand. Okay, these are ordered, right? But we want to make a box and whisker plot for this data. So the way I like to do it is to label the important points or locations with just a point and then make the whole plot. So first thing that we need that I'm going to draw, and maybe I should get my snap ruler. Actually, it's okay. I'm going to show you guys. It doesn't have to be. One more time. See if I can do it fast. All right, that looks a little bit better. So I'm going to make a scale. We go from 2 to 12. So if I go 1, 2, 3, there's 6, 7, 8, 9, 10, 11, 12. Okay, and we can just label if we want every 2. All right, but guys, it's really important that you include this scale. If you draw a box and whisker plot, and there's no scale, you're going to lose points. Okay, the scale is really important. I guess I'm just, for the sake of symmetry, going to make 2 more. Okay, so what I want to look for, right, is the min, the Q1, the median, the Q3, and the max. So the min we've got, it's 2, it's easy. The max is 12, I'm going to plot that. And so like you can see, I'm just making these dots, and I'm going to make the shape later. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 data points. Good. That means we have exactly 1 median. So we're going to go 1, 2, 3, 4, 5, 6. Then there. 1, 2, 3, 4, 5, 6. So our median, as we can see, is 7. So I will label that with another dot. Should I get into the how to find? Yeah, I will. Okay, so another way to find these 2 quartiles, guys, if we have data like this, is now, remember, the median cuts the data into here's 50% of data, here's 50% of data. This is kind of like a shared value. You could think of it that way, right? But now, if I ask, well, what's the middle of this first half of the data? Well, you guys would tell me it's right in between there. Right, so right there, that's actually our Q1. And we can see from that it's 4. And similarly, if we take the second half of the data and we cut it, we get Q3 is actually 10. Remember, we've talked about before how to find the middle if we have even values, right? We take the middle, the 2 middles really. So here are the 5 important points. Okay, min, Q1, median or Q2, Q3, and Q5. And then what I do is I just draw the box, right, using these vertical lines. Okay. I'll make it a little bit, hopefully a little bit even, more even. Okay. Maybe clean this up a little bit. Great. I didn't want to erase the whole thing, but I did. The whole line. There you go. Actually, yeah, sorry guys, I don't like this one too. It's kind of offset. All right. And then if you really want, you can label these two just to be totally clear. This is 4, this is 7, this is 10. This is 2, and this is 12. Well, what have I forgotten? I made the box plot. I still need to do the whiskers, right? So all we do for the whiskers is we just connect. Okay? So there is, and then if you want, you can even remove the dots if you want. You can remove those. Right? You don't need the dots inside the box anymore if you don't want them. Okay, so just getting it as clean as I can get. Right? There you go. Okay, so next, well, let's interpret one that we have, right? So here we have a box and whisker plot. Waiting time for a taxi or Gojek outside, or go car, I should say, outside GIS. There's no way I'm waiting 100 minutes for a Gojek, or even, to be honest, I'm not waiting 17 minutes for a Gojek. So this has to be for taxi, probably on a very rainy day. The approximate median waiting time, well, we're just going to read this, right? So that looks like there's 65, there's 70. I'm going to say that's about 68, right? You guys might disagree, and that's okay, but it's close to 68. And find the approximate IQR, so that's going to be this Q3, right? It's basically the length of this box. It's the length of this box. So we're going to take this value, which looks like, I'm going to say that's 86. So this is 86 minus this value here. Well, that looks like 51 to me. So this is about 35 minutes. Hey guys, I just realized, sorry, this is in seconds, so you know what? Okay, I'm fine. Man, this is pretty fast actually. Thought it was minutes. I was like, no way. Okay, this is seconds. That's a lot better. That is a lot better. Okay. So we can also use box plots to compare data, right? Compare data. So in this case, we've got 3 classes, and we have their the summary results for how they did on a test. Same test. Which class had the highest score? Well, that's the max, right? That's right here. This is the highest score, so I'm going to say it's class 2. Which class had the smallest range? Well, that means the length of the entire box plot, right? So which had the smallest range? I'd say it's class 1. So their data was most close together. All right, if you want to pause this and work through it on your own, go for it. Which class had the highest median? Well, highest median, that's the middle value. That's right. Oops, I want the laser. That's right there, so that's class 3. Highest Q3, that's also class 3. Remember, Q3 is the quartile 3 there. Highest IQR, interquartile range. So essentially, that means the length of the box, right? Because that's Q3 minus Q1. So this is a pretty small IQR right here. This is a little bit larger. This is the biggest. They had the biggest range from the 25th percentile to the 75th percentile. So class 3 is having a lot of these stats being led by them. Which appears the most symmetric? No, because the lengths of these whiskers are way off. Probably not there, because there's no whisker on the left. And I'd say this, right? Also the middle box looks somewhat the same. So it's not perfect, but I would say class 1 is the closest to symmetric. Why? We could say Q1 to Q2 and Q3 to Q4 are about equal. And then whiskers are closest, right, in length of the 3 classes. That's what I would say. Okay, and then maybe the toughest question to answer, right? But which class did best? So they all 3 have the same lowest value, 60, right? But we had this person got 100% in this class. You could say this class and this class had the same amount of people that did in the 25th percentile, right? You could go by Q3, you know, but this is not a always easy question to answer. If it's me, I'm gonna say this class, just because their median was the highest. It's very, very close, right? And they also had a higher group here and here, really. But yeah, I wouldn't say this class, because this is just one student that did really well, and then a lot of them didn't, right? So I'd say class 3. Class 3. And I would say highest median. And I'd say best Q3 to max performance. Okay, and yeah, that's something that we could disagree on, but that kind of shows you why having a good knowledge of stats and what different ways you can present data can do in terms of interpreting data. All right, let's see, what do we have left? I'm thinking about making one more video, cutting this up. So we have a definition of an outlier. Actually, that's it. No, let's finish it here. Okay, so an outlier, right? A sort of soft definition is written here. It's a value that's much bigger or smaller than the general body of data, right? So, you know, we've talked about before in this class how we like specificity, right? And bigger, smaller, general body, those are all very general, right? We want precision. So here's a better definition, okay? And the definition says, for a data value to be an outlier, it has to be larger than Q3 by 1.5 times the IQR, or smaller than Q1 by 1.5 times the IQR. All right, so guys, essentially what we do, if you want to imagine it visually, is we take, let's say, here's Q3, right? And here's the IQR, sorry. Here's the IQR. So we would take that distance and we'd multiply by 1.5. And then we'd add that distance on to Q3, and we'd subtract it from Q1. And if there were data values that were beyond that, they would be outliers. So in this case right here, you can see if I take that distance, even if I double it, and I add it on here, this student is still an outlier. The student's grade is so far from the Q3 that it's an outlier. All right, so let's formalize that a little bit. We can say outlier is either greater than Q3 plus 1.5 IQR, or it's less than Q1 minus 1.5 times the IQR. Okay, so that's how you determine, and you can compute those numbers, the numbers on the right, you can compute these values and then just compare and see if you have any individual values that are beyond either of these. Okay, so I'm gonna have to give you some time to put these in and find the summary stats. But yeah, we have 20 pieces of data. We don't know what they are, but we want to find the Q1, the Q3, and the IQR. Okay, so you're going to do your same thing, calc variable, or calc stats, one variable stats. And one thing to maybe consider here, guys, is you could use a second column with a frequency chart. So maybe I will make a video of that, but we could say there's 2 3s, there's 3 7s. We could save some time with inputting this data. All right, so pause the video now, put that stuff in, and find these 3 summary stats. All right, if you found them, what I'm getting is Q1 is 6.5, the median is 8, and Q3 is 10. So that means the IQR is going to be, right, Q3 minus Q1, 10 minus 6.5, 10 minus 6.5 is 3.5. Okay, so we have our Q1, we have our Q3, and we have our IQR. Just want to be sure that that looks like a 3.5 and not a 35. Yeah. That looks even worse. Let's make that 3.5. Okay, so we want to test for outliers now, right? Test for outliers. So I'm going to take Q1 minus 1.5 times IQR. So that's 6.5 minus 1.5 times 3.5. 1.5 times 3.5 is 3.5 plus 1.75, which is 5.25, I believe. So this would be 6.5 minus 5.25, which is 1.25. 1.25. All right. Do we have an outlier? Do we have anything lower than 1.25? Yes, we do. Right? This is an outlier by the formal definition. All right. If we do the opposite, then we go higher than 1.5 IQR plus Q3, we could say, all right, well, let's find that value first. So that's going to be 6.5 for the low, so 10 for the high, right? That's our Q3. 1.5 times 3.5 is 5.25, and we're adding that now. So that's 10 plus 5.25, which is 15.25. So that's our value beyond which, if anything's higher than that, we have an outlier. And it just so happens we do, right? 16 is bigger than that. Okay? So we actually have two outliers. And I'll put that, I guess, right over here on the right side. So we'd say 1 and 16 are outliers. So they are just values that are way outside the general trend or the majority of the data. Okay, guys? So there we go. Outliers are also a good way for us to determine, the shape of a graph. That's going to create skew usually. So I hope that was helpful. I will make a video of going through this example and using a frequency list too to make computing these summary statistics a little bit easier. But hope you guys are well and hope this video was helpful. Okay.